Hey, hello ib3 students, welcome to my next video lesson about moment of inertia. Okay, today I'm going to solve with you a problem related with masses which are hung to the pulley. Something we did in ib1. We did by using a classical method without moment of inertia. Now I'm going to evaluate this to the problems related with moment of inertia. But at the beginning, let's imagine a problem without moment of inertia. No moment of inertia. Okay, let's imagine a problem that you have a kind of disk and two masses attached to the disk. M1 here, M2 here. Let's imagine that M1 is heavier, 5 kilograms, M2 smaller, 2 kilograms. Let's use gravitational acceleration G equals 10 meters per second squared. And our task will be to calculate acceleration of the system. Okay, system will be accelerating in this direction, but not by using forces and equation with forces, not by using gravitational force and tension, but by using law of conservation of energy. Of course, I know that this method is not the best one, it's time-consuming and maybe difficult one, but it's important because last lesson we were talking about problems related with moment of inertia and rolling objects. We've used only law of conservation of energy. Today I'm going to present a new material also by using law of conservation of energy. So to warm up, please solve this simple problem. So the task is find acceleration of this system by using law of conservation of energy. Okay, let's take time. Okay, 10-12 minutes. Stop video, prepare to the, I hope that you are prepared to the lesson, pen, pencil, ruler, calculator, your notebook. Stop this video for, let's say, 15 minutes and please solve this problem. So find acceleration of this system by using only law of conservation of energy, not forces, not second Newton's law of motion, just law of conservation of energy. In 15 minutes I'm going to solve this and you will check. Okay, so 15 minutes later. Okay, finished? I hope yes. I need a little more space, so move it a little here. Okay, so let's imagine that mass 1 falls from height of h. Okay, at the time when mass m1 falls from height of h, mass 2 moves on height of h because both are connected with the same string, which is unextensible. Okay, so let's look. At the beginning, we have potential energy of the system related with mass m1 and m2. So at the beginning, we have potential of energy of m1, m1gh, and potential energy of mass m2, m2gh. So this is our potential energy at the beginning. So let's imagine that end of our situation is when mass 1 touches the ground, so when mass m1 travels h, distance h, down, and mass m2 at the same time travels distance h up. So finally, what do we have? We have mass 1 which hits the ground with speed v1, so this is half of m1 v1 squared. Okay, and mass m2 has both and potential energy because it is placed at distance of 2h, initial h and final h, and it also moves with speed of v1, so I'm going to use index maybe v. Okay, not v1 but v, because mass m2 moves with the same speed but up. Remember, in the case of kinetic energy, we have speed, not velocity, so direction is not important. So again, when m1 touches the ground, then m1 has kinetic energy, m2 has kinetic energy, and m2 has also a potential energy. So energy at the beginning is equal to energy at the end, so we can write one equation, m1gh plus m2gh must be equal to half of m1v squared plus m2g2h plus half of m2v squared. Oof. Okay. So we have m1, m2, we have g, we have v, and we have h. So we have to include to our equation acceleration, and we want to eliminate height, and we want to eliminate v squared. Okay, what is the height? Height is distance traveled by mass m1 or m2, starting with velocity equals to 0, and velocity at the end is v squared. So in general, we can write that h is equal to, or other equation, v squared in a uniform accelerated motion is equal to u squared plus 2a times h, and of course our u squared is equal to 0. So by using this equation, we can substitute that v squared is equal to acceleration times height. So I'm going to replace v squared here and here by 2ah. So equation looks like m1gh plus m2gh is equal to half of m1 and v squared, which is 2ah, plus m2g2h plus half of m2 v squared, which is 2ah. Okay, you see that now h can be crossed because it's here, 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 and here, and we have equation with m1, m2, g, which are given, and a, which is unknown. Okay, so substitute data and let's look what happens. So m1 is 5, g is 10 without units, m2 is 2, g is 10. Here we have half of m1, which is 5 times 2 times a, plus m2, which is 2 times g, which is 10 times 2, plus half of m2, which is 2 times 2 times a. Okay, 5 times 10, 2 times 10, so this is 50 plus 20 is equal, you can cross this, you have 5a plus 2 times 10 times 2 is 40, plus we can cross this 2a, finally obtaining in one hand 70 minus 40, which is 30, in other hand we have 7a, so finally we have 30 divided by 7 is equal to 4.3 meters per second squared. 4.3 meters per second squared. Okay, this is our solution. This system accelerates with acceleration of 4.3 meters per second squared. Of course, if I didn't do some mistakes in the calculations, I don't think so. If you see that something is wrong, please write me below the movie as a post for Google Classroom. Okay, so now probably you expect what happens. Let's solve the same problem, but this pulley, this ring or disc, has own mass, and we have to take into account the moment of inertia of this disc. Is it clear? Okay, so we have exactly the same situation. Yes, we have two masses, so I'm going to change a slide. Okay, so now with moment of inertia. So we have a disk, two masses, m1 and m2. A disk has a radius of r, which probably will be not necessary, and mass of capital M. and let's take the same masses. So m1 is equal to 5 kilograms, m2 is equal to 2 kilograms. Okay, let's take that this disk has a mass of 10 of kilograms. Let's use g, 10 meters per second squared. Something else? Okay, radius will be not necessary. We know that system accelerates. Okay, the question is about acceleration, but again the same problem. I know that this method is not the best one, not the fastest one, but the method can be used analogically to something we did in our last meeting, our last lesson, and something we did 10 minutes ago. Use law of conservation of energy, not forces, not second Newton's law of motion, just law of conservation of energy. Analogically, that's something we did 10 minutes ago. And remember that moment of inertia of the disk, okay, is given as half of mr squared, when r is a radius of the disk and m is a mass of the disk. Radius will be crossed somewhere, so you don't need to know data. Okay, this is a little bit more challenging, so we have more time. Let's say 25 minutes. Okay, so please copy this, stop video for 20-25 minutes, and after 25 minutes please turn it on again, and we'll try to solve working together. I hope that you will have solutions in 25 minutes. Okay, so 25 minutes later. Exactly the same method as in our previous example. At the beginning, the energy stored in the system is potential energy of mass m1 and potential energy of mass m2. Let's imagine that both are on height of h. So the total energy of the system is m1gh plus m2gh. Okay, at the end, when mass m1 touches the ground, or after traveling h, the length of h, we have mass m1 has speed, so half of m1 v squared, so kinetic energy. Mass m2 has a speed, so half of m2 v squared. Speed of m1 is the same as speed of m2 because both are connected by an extensible string, so speed must be the same. Mass m2 is at certain height, so it has potential energy, but remember that height is 2h. It was at height of h at the beginning, and now it was traveling the length of h up, so now the height above the ground is 2h, but we have to take into account also the rotational kinetic energy of this pulley, because it's moving, it's rotating. Okay, it has moment of inertia. It takes some energy from the system. It took some energy from the system to be rotated. So we have to take this, and I hope that you remember that the rotational kinetic energy is given by half of moment of inertia, omega squared, where omega is angular velocity and I is moment of inertia. So in this equation, in last equation, I, moment of inertia, is half of mr squared. Okay, and what is omega? If v is omega r, then omega is v over r. Okay, remember about squared it. And of course, law of conservation of energy says that energy at the beginning is equal to energy at the end, so you can write our equation. m1gh plus m2gh is equal to half of m1 v squared plus half of m2 v squared plus m2 g2h plus half of, and now moment of inertia, half of mr squared times omega squared, so v squared over r squared. Okay, we can cross something. You see, radius of the disk is not necessary, and we have to use the same method, that v squared is u squared plus 2a h. If initial speed is equal to 0, then we have v squared is equal to ah, because normally it's v squared equals u squared plus 2ah. In this case, initial speed is equal to 0, so v squared is equal to 2ah. So, one more line, m1gh plus m2gh is equal to half of m1 v squared. Substitute v squared is 2ah plus half of m2 2ah plus m2g 2h plus here 1 over 2 times 1 over 2 is 1/4 capital M, and v squared is times 2ah. Okay, you see that h is in each part, here, 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 and here. We can cross it. And now we have only one unknown, acceleration. So, data, m1 is 5, g is 10, m2 is 2, g is 10, is equal to half of m1 is 5 times 2a plus half of m2 is 2 times 2a plus m2 is 2 times g, which is 10 times 2, plus 1 over 4, and m mass of the disk was given here as 10 kilograms. So 10 times 2 times acceleration, and all you have to do is to calculate. So 5 times 10 plus 2 times 10 gives 70. Okay, here we can cross this and we have 5a. Here we can cross this and we have 2a. Here we have 40. So this is the part we had in our previous exercise, but we have one more part, this one. Okay, 1 over 4 times 2 gives half, and half times 10 gives 5, so 5a. So now 30 is equal 7a plus 5a is 12a, so in this case is 30 over 12, which is 2.5. Yes? Yes, 2.5. So acceleration is 2.5. So compared with previous example is much more or less, because this disk was quite heavy compared with masses. So remember, to spin something, to rotate something, we need a certain amount of energy, and the source of this energy is energy of the system. So finally, acceleration of the system must be smaller because part of the energy is taken by this disk. Okay. And now your homework. Something which will be not too difficult. First of all, I hope that you have the same result. If not, please copy this. Stop video, copy this, and after this I'm going to give you a homework. Okay, so what is your homework? You have to do exactly the same exercise. So we have a disk, okay, with two masses, exactly the same masses, m1 5 kilograms and 2 kilograms. Okay, so exactly the same problem. Use g as 10 meters per second squared, it will be easier to calculate. No moment of inertia. Okay, and your task is to find the same acceleration of the system. Remember, no moment of inertia. Yes? You have to find acceleration of the system without a moment of inertia, but by using forces. Okay, I want to see free body diagram related with each of these two masses. So you have to include gravitational force, you have to include tension somewhere, you have to use second Newton's law of motion, and solve the same problem, find acceleration by using second Newton's law of motion and forces. This is your task for tomorrow. Tomorrow I'm going to check this, I'm going to present the correct answer, and we will calculate, we will solve the same problem with moment of inertia, but not by using law of conservation of energy, but by using forces, which will be, you will see, will be quite challenging, but finally very, very, very logical and much more easier method than one by using law of conservation of energy. Okay? If you have any questions, comments, please write in the form as a form of post below this movie in Google Classroom. Thank you for watching. Remember about your homework. Stay at home and see you next time. Bye.